Hi students, this is Madhurao Allah. Okay, up to now I explained the concepts of signals and systems. In signals and systems, I explained concepts or topics regarding classification of systems with the help of smart board. So I explained the topics of signals and systems with the help of smart board up to now. Right from now onwards, I am going to explain the remaining topics of signals and systems with the help of glass board. That is what you are seeing now. Okay, the first one. Now, in the previous classes, what we discussed. So where we stopped in glass board. Sorry, where we stopped in smart board. There, in that smart board, I am explaining you the concept of classification of systems. There are various classification of systems. Okay, in that I explain you three types, that is continuous time system and discrete time system. Okay, next linear and non-linear system. Next time invariant and time variant systems. So with respect to classification of systems, I explain these three classification using smart board. Now right from now onwards, the remaining classifications and the remaining topics in signals and systems, I am going to explain using the glass board what you are seeing now. Okay, so now what are the remaining classifications of systems except those three? What are the continuous time system and discrete time system, linear, non-linear, time invariant and time variant? We are finished. Now what are the remaining classifications? So the remaining classifications are static and dynamic, causal and non-causal, stable and unstable, invertible and non-invertible. So we are left with four types of classifications. Okay, so those classifications are: first one static and dynamic, next causal and non-causal, and next stable and unstable, and finally the last one is invertible and non-invertible. So I have to explain these four classifications. Okay, I will explain these four classifications with the help of this glass board. Okay, right from now onwards, your subject signals and systems and all the remaining topics in the signals and systems will be explained by using this glass board. Why? Because so in the coming classes, not in these classifications, after that we will have analogy between vectors and signals. There we need a number of equations, there is a long derivations. So for the derivations, this board is very much helpful. For that, they are provided this glass board, and we are going to continue with this glass board for problematic subjects like signals and systems. Okay, so now I am coming to the topic, today's topic. So today's topic is with respect to classification of systems. So I am going to explain you the classification of systems. In that classification of systems, our first, I already explained three classifications, and the next one, that is today's topic is static and dynamic. Static and dynamic system. So I will start with the static and dynamic system. Okay. Yeah. What is a static system? What is a static system? So can anyone tell me what is a static system and what is a dynamic system? What is a dynamic system? Okay, now before going to the technical explanation regarding static and dynamic, I will ask you, what is the general meaning of static and dynamic? What is the general meaning of static and dynamic? And its general meaning. So while calling a person, I can say that person is a dynamic person. What is the meaning of the dynamic person? Dynamic person means he can capable of doing anything. He can do the works whatever we give to them, and he can adapt to the situations very easily. So he can change, he can vary according to time. That means he can collect the past values and he can think about the future, and while running on the present, he can collect the past and think about the future. So he can adapt to any type of situations. That is, he is a dynamic person. So if anything varies, he can vary himself. Generally we can say he is a dynamic, he is capable of doing anything. And static means constant. Static means constant. He is a constant, static. He will do the work what that is specified to him at that present time. At that present time. So if I assign a work at the present time, he will do the work at that time only. But a dynamic person can do that work by collecting the values of previous ones and thinking about the future, and he analyze everything and he will think dynamically. But a static person don't think various. It means a static person will think only what that had given to him. That is, he will think about the present situation only. That present situation. Okay. So, but the dynamic person can think about past and future also. So, based on this, I will explain the concept of static and dynamic technically. Okay. So, I hope you are clear with what a dynamic person is, what a static person is. Now, I will apply this example to our system, static and dynamic systems. Okay. First, I have to go with static system. Okay. Static system. Now, see, what is the static? A person is static means he will do the work what that is assigned to him at that present value. Okay. He's a constant. A static person is a constant person. That means he will do the work that is given to him at that present time. So he will do the work only according present situation, at that present situation. So whatever the present input that I had given to him, he will produce the output according to that present input only. So the output is also present output. At that time, he will produce. If I give some work, he will do it and he will give it. Okay. So this is regarding a general static person. Okay. Now go for the dynamic system. Okay. What is the general meaning of dynamic? A dynamic person is a varying. He is not a constant. He can vary according to the situations. He can change himself according to the situations. He can change himself according to the situation. That is, he can think about the future. He can collect the information from the past and apply that to the present to give a better future. Okay, he collects some information of past. That means he needs some memory, because he needs more memory, because he has to collect some information from the past. Okay, past, he will take the information. Okay, so he has to collect. That means he needs some memory. And apply that to the present, and it will be better suitable for the future. He will think like that. That means here the dynamic person can go for past, present, and future. Past, present, and future. So he is past, present, and futures. He will go for everything. Okay. He will collect the information from the past and apply to the present to get the better future. Okay. So he will go for all this. Now, apply this technically to a dynamic and static systems. So first apply this to a static system. So I said static means that is, he will do the present work only. That is, does he need any memory? No, he does not need any memory, because he does not collect the past values or past information. He does not collect the past information. So there is no need of that memory for the static ones. So whatever we had given to them, they will do it and give it. That is, static is with respect to present. That means they doesn't need any memory. That means static system is also called as memoryless system, because the static one will do the work regarding the present situation only. So they does not need any memory. Hence the static system is also called as memoryless system. So in some cases that static system is also termed as memoryless system. Okay, this is the memoryless system. First thing, memoryless, because they don't need the memory, because they don't use the past values. Okay, first thing. Next, coming to dynamic, so he can take the past values. For that he needs some memory, so dynamic systems need the memory. So dynamic system is also termed or is also called as, sometimes we call the dynamic system as memory system. Okay, memory system. So first thing, I hope now you have an idea about what a static system is and what a dynamic system is. Okay, now I mean, based on the example of static person and dynamic person. Now I had given another names for static system. Static system is also called as memoryless system, whereas dynamic system is called as memory system. So now based on all this explanation, can anyone tell me what is the definition for static system? Can anyone tell me what is the definition for static system? When a system is said to be static, a system is said to be static system if the output depends only on the present input. If the output depends only on the present input, then we can say that system is a static system. Let us take, how will you represent the output? The output is represented with y of t for continuous and y of n for discrete. See, before going to actual definition of static and dynamic, I want to make you one thing clear. I will explain the topic first with respect to continuous time variable rather than discrete. Why? Because in continuous and discrete, you are more familiar with the continuous time variables, because all the general signals are continuous time signals. So you are all familiar with the continuous time variable. Hence, I will explain the concept with respect to continuous time variable, that is with respect to t. So there is no need to again explain for discrete, because for discrete also the concept is same. So only the change is, whenever we get small t, I have to replace that with small n. Whenever I get small t, I have to replace it with small n. Let us take an example for that. So the example is, if there is an equation y of t equal to 2 into x of t. So can anyone tell me whether this is a continuous or discrete? This is a continuous one, because here we have a variable small t. If I explain some concept with respect to that equation, now you want to apply the same concept with respect to discrete. Only the change is, this equation will be termed as y of n equal to 2 into x of n. That is, the small t is varied with replaced with respect to small n. Small t is replaced with small n, and the concept is same. So for that reason, now I will explain with respect to continuous time variable t. So I will explain y of t equals some equation like that. Okay, so you will apply that to the discrete time. Okay, now coming to this one. So what is a static system? A system is said to be static system if the output depends only on the present input. Let us take, this is the example. So here I am considering the example as y of t equal to 2 into x of t. Y of t is the representation of the output signal, and x of t is the representation of the input signal. Okay, now let us take, the output depends on only the present value. That is, if I need the output at the t equal to 1 second, then the input is 2 into x of 1, because at 1 second, here the output at the first second is dependent on the input at the first second only, because the equation is like that. If I need the output at second, then according to the equation, that is 2 into x of t. So here that output at the second is dependent on the input at the second. Okay, so that is, here the outputs depends only on the present value. So this is the present value of the output and this is the present value of the input. Here is also 1, here is also 1. That is, the output depends on the present value. Hence, those type of systems are called as static system. So this is an example for static system. This is an example for static system. Now coming to dynamic. So can anyone tell me the definition for dynamic system? Simple. A system is said to be dynamic system. A system is said to be dynamic system. Dynamic system if the output depends on past and future values. Depends on past and slash or future values. That is both either past or present, future, or both past and future. Then we can say that system as an dynamic system. That system as an dynamic system. Okay. For that, let us take again an example. Okay. I guess an example. See the example as y of t equal to say 2 into x of t plus x of t plus 2. X of t plus 2. So this is the equation. Y of t equal to 2 into x of t plus x of 2. So this is what they had given the equation. Now see. Now at first second, at t equal to 1 second, that is y of 1 equal to 2 into x of 1 plus x of 1 plus 2. 1 plus 2 is 3. I am writing directly. 1 plus 2 is 3. Okay. See, y of 1 equal to 2 into x of 1 plus x of 3. Here, the output at the first second is dependent on the input at first second and input at third second. Input at third second. Now, consider the time. So, this is the 0 second. This is first, this is second, this is third. Or minus 1, minus 2, minus 3. Clear? Minus 3. Now, see, x of 3. So, this is our present output, y of 1. Here I have to get the y of 1. Now, y of 1 will be equal to 2 into x of 1. At that first second, I need the input. Now, y x of 3. X of 3, this is the 3, third second. So, that is future. That is future because it is greater than 1. That is the future value. That means here the output at the first second is dependent on the input at the first second and third second. That is the output depends on the present and future value also, future value of the input. So as the output is dependent on the present and future value of the output, we can say that as an dynamic system. That as an dynamic system. Simple. Okay. So a system is said to be dynamic system if its output depends on the past or future values. Here it is dependent on the future values. You can go for another example also. So if you go for another example, y of t equal to 2 into x of t plus x of t minus 3. X of t minus 3. See, at first second, y of 1 will be equal to 2 into x of 1 plus x of 1 minus 3. 1 minus 3. 1 minus 3 is minus 2. 1 minus 3 is minus 2. That means here the output at the first second depend on the input at the first second and input at the minus 2 second. That is here 0. First y of 1, that is at this point. X of 1 at this point. What is x of minus 2? X of minus 2 is here. Here, this is the 1, x of minus 2 here. That is, it is dependent on the past value. So here the output depends on the present and past. So that is also an example for dynamic system. Or you can write the equation as, see, combination y of t equal to x of t minus 2 plus x of t plus 3. You can write like this, past and future. You can add present also, past, present, future. So these are all the examples for dynamic systems. I hope you are all clear with what is a dynamic system and what is a static system with examples. So simple. A system is said to be static system if the output depends on present input only. Those systems are called as static systems. And coming to the dynamic system, which system is called as dynamic system? Simple. If a system is said to be the dynamic system if the output of that system depends on past or future values. Past or future values. Those systems are called as dynamic systems. Those systems are called as dynamic systems. So you can get n number of examples. Okay, here I had given one example, here I had given two examples, so you can take any examples. Okay, now all these are with respect to continuous time variable t. If I want to explain the same thing with respect to discrete, so how can I change this one? So this one, first one, example of static, y of t equal to 2 into x of t. So I have to write y of n equal to 2 into x of n. Okay, if n equal to 1 at that instant, so y of 1 equal to 2 into x of 1. So the output depends on the present input. So I can say this is a static. For at that particular instant, let us take y of 2, 2 into x of 2, y of 10, 2 into x of 10. The output depends on the present, that is the output at the 10th unit is dependent on the input at the 10th, that is the output depends on the present input. So this is a static, this is a static. And here it is dependent on sometimes past, sometimes future, and sometimes both past, future, and sometimes past, present, future, everything. If in that equation there is a term of either present, either past or future, either past or future, if you see any one of it or both, you can say that is a dynamic system. So this is for continuous. Can I rewrite this equation for discrete? So same equation. How can you write for discrete? For discrete you can write y of n equal to x of t minus n plus x of, sorry, how can you write for this? Y of n equal to x of, in place of t I have to write n minus 2 x of n minus 2 plus x of n plus 3 x of n plus 3. Are you clear? Simple. So if you want to rewrite this equation, how will you rewrite this one? Y of t, in place of y of t I have to write y of n. Okay, I'm writing again, y of n equal to, what I have to write? 2 into x of n, 2 into x of n plus 2 into x of n plus x of n plus 2, 2 into x of n plus x of n plus 2. Okay, so I'm writing as y of n equal to 2 into x of n plus x of n plus 2. Okay, so this is, and the explanation is same for discrete also. So you can say this is a dynamic system with respect to discrete. So this is regarding static and dynamic systems. Okay, now you will see the definitions. So you know what is static system? A system is said to be static system if the output of the system depends only on the present input. The output of the system depends only on the present input, that is the output depends on present input only, then I can say the system as a static system. And the example I explained you, y of t equal to 2 into x of t for the present value, let us take t equal to 0. The system output is y of 0 equal to 2 into x of 0, that is y of 0 dependent on x of 0. If the present output depends on present input, that is output depends on present input only. If y of 1, then it is 2 into x of 1, y of 10, 2 into x of 10. Here the output is only dependent on present input, hence the system is a static system. If you want another example, I will give you another example also. So y of t equal to x square of t, that is for t equal to 1, y of 1 equal to x square of 1. Okay, for t equal to 2, y of t equal to x square of 2. For n or for 9, y of 9 equal to x square of 9. That is, here the output depends only on the present value. Hence we can say that system as a static system. It does not need any memory. It depends only on the present value. Hence it is a memoryless system. So static system is also called as memoryless system. So if in case of discrete, how can you write for discrete? Y of n equal to 5 x square of n. Y of n equal to 5 x square of n. So this is for a static system example for discrete. Okay, so this is one. Now move on to the dynamic. So dynamic. Now I already explained you what is a dynamic system. A system is said to be the dynamic system if the output depends on past or future values. Past or future values, then I can say that as a dynamic system. So if the output depends on past or future input values, okay, future inputs. And example is y of t equal to 2 into x of t. So there we have taken example y of t equal to 2 into x of t plus 3 into x of t minus 3. So is what we have taken. So for the present value of t equal to 0, what is the output? Y of 0 equal to 2 into x of 0 plus 3 into x of 0 minus 3, that is minus 3. So the answer is y of 0 equal to 2 into x of 0 plus 3 into x of minus 3, 3 into x of minus 3. So go to the number system. Let us take 0, 1, 0, 1, 2, 3, minus 1, minus 2, minus 3. See, you are taking the output at 0, y of 0, that is equal to 2 into x of 0, that is the present input. And next one is x of minus 3. X of minus 3 is at this point. X of minus 3 is that is here the output depends on present input and past input, because this is the 0 is present. So minus 3 is past. So the output depends on present input and past input also. That is the output depends on the past input, hence it is called as a dynamic system. Dynamic system. Or you can take for 1. T equal to 1. So y of 1 equal to 2 into x of 1 plus 3 into x of 1 minus 3, that is minus 2. Minus 2. 1 minus 3 is minus 2. See, now the output at 1, that is y of 1 equal to 2 into x of 1. 2 into x of 1, that is a present input. Now that plus 3 into x of minus 2. So this is the output and it is given a present input. And what about x of minus 2? Minus 2 is this one. Minus 2, that is the past value. So here also the output is depending on the past values. That is for any one value of t, if it is dependent on either past or future, you can say it as a dynamic system. So in this example, it is dependent on past values. Hence we can say this is a dynamic system. So here x of minus 3 and x of minus 2 are the past values for the present input. Past values of the present input. So the system is said to be a dynamic system. For storing these past values, it needs some memory. So the system requires some memory because it has to need the past values. Okay, to give the perfect output, it needs the past values. For that, it needs memory. So it is also called as memory system. So the system requires memory to get the output. Hence, it is also called as memory system. So dynamic system is also called as memory system. So this is with respect to what? Continuous time variable. Now, in the same example, if I want to explain with discrete, just I will replace t with n. T with n. So, how will you write the equation? Y of n equal to 2 into x of n plus 3 into x of n minus 3. Same, the concept is same. So n equal to 0, n equal to 1, n equal to 2. What is the value? N equal to 0. Y of 0 equal to 2 into x of 0 plus 3 into x of minus 3. Same concept. So it is, as it is dependent on x of minus 3, x of minus 3 is the past value. So you can say it is a dynamic system. So this is regarding about static and dynamic systems. Static and dynamic systems. Okay. Next, we move on to the next one. That is causal and non-causal system. Causal and non-causal systems. Okay. Yeah. So now the next classification of system is causal and non-causal system. Causal and non-causal system. Okay. Now, which system is called as causal system and which system is called as non-causal system? See, there is some interference for static and causal. Okay. So don't get confused. I will clearly explain what is causal and non-causal. So based on that, you can designate or differentiate static and causal, dynamic and non-causal. These are two separate. So on explaining, you can get some persons will get some confused with that one. Okay, so now I am to explain you what is a causal. A system is said to be causal system. A system is said to be causal system if its output depends on present and past input values. A system is said to be causal system if its output depends on present and past input values. Whereas for static, the output depends on only the present value. But for causal, it can depend on present and past values. If the output of the system depends on both the present and past input values, then I can say that system as a causal system. That means the system output does not depend on the future input. Here, if the system output depends on the present or past inputs, then I can say that system as a causal system. Remember, if a system is said to be a causal system, whenever if the output of the system depends on only the present and past inputs, it does not depend on the future input. Those type of systems are nothing but the causal systems. Okay, so causal systems, the output does not depend on the future inputs. Clear? First thing. So if you want to say it as a definition, a system is said to be a causal system if the output of the system depends on the present and past inputs. Okay. Now what about non-causal? Simple. Non-causal. That is, a system is said to be the non-causal system if the output depends upon the future inputs. If whenever there is a future input in the system output, then we can say that system as an non-causal system. A system is said to be non-causal. Okay, the output depends upon future inputs. Okay, whenever the output depends on the future input values, then I can say that system as a non-causal system. So see, first I will give the examples for causal, and then I will go for the example for non-causal. After that, I will compare static, dynamic with causal and non-causal. Okay, for your better understanding. Okay, see the example for causal system. Okay, causal system. So I will explain this with taking an equation, system equation. Take system equation. There the equation is y of t equal to 2 into x of t plus 3 into x of t minus 3. Y of t equal to 2 into x of t plus 3 into x of t minus 3. So they have taken the present value as t equal to 1. For t equal to 1, what happens? Y of 1 equal to 2 into x of 1 plus 3 into x of 1 minus 3. So 1 minus 3 is minus 2. So the system output is y of 1 equal to 2 into x of 1 plus 3 into x of minus 2. So take the number system. 0, 1, 0, next 1, 2, 3, minus 1, minus 2, minus 3, minus 1, minus 2, minus 3. See there the system output is y of 1. So here y of 1, because I consider the first second t equal to 1. Consider the first second. Okay, t equal to 1. Y of 1 equal to, what happens? 2 into x of 1. So x of 1 is this one. X of 1 is that one. That is the present value. And then plus 3 into x of minus 2. X of minus 2 is here. That means 1 is the present value, then minus 2 is the past value. That is, the system output depends on present and past. So we can say that system as a causal system, because whenever the system output depends on present and past values, that is a causal system. Okay, causal system, present and past values. Clear? Hence the system output depends upon present and past inputs. Present and past inputs. Is there any future? No, there is no future input. So there is no x of 2, x of 3. There is no future input. Hence, the system is a causal system. Or in place of t equal to 1, you can take t equal to 2. So for the same equation is y of t equal to 2 into x of t plus 3 into x of t minus 3. This is the equation. For t equal to, they had taken 1, I had taken 2. T equal to 2. So y of 2 equal to 2 into x of 2 plus 3 into x of 2 minus 3 minus 1. See, at 2, y of 2 equal to 2 into x of 2, present. And x of minus 1 is this one. This one is a present one. And this one is a past value. So here also the output depends on present and past input values. Present and past input values. Hence that system is an example for causal system. Hence the system is an example for causal system. Can I say this as an static? No, we can't say this as a static, because static system depends only on present value. But you can say this system as a dynamic system, because it depends on past values. It depends on past values. So we can say this system as a dynamic. That is, this system is both dynamic system and causal system. So the system is both dynamic and causal system. But this is not a static system, because here it is depends on past values. I hope you are clear with what is static, dynamic and dynamic, and causal and non-causal. So the system you can say as both dynamic system as well as causal system. Okay. So you can go for another example also. You can go for any number of examples for this. So y of t equal to 3 into x square of t, 3 into x square of t plus x of t minus 2. Okay, that will be equal to, at t equal to 1. So you can check for 1, 2, 3, 0, minus 1, minus 2, anything. So if for at least one value of t, if the output depends on future, then it will become as a non-causal. That is, for not even a single value of t, the output has to depend on future. That means for all and every values of t, whatever the time is, every values of t, the output depends only on present and past values. Then the output depends on only present and past inputs. Then we can say that system as a causal system. If at least for one value of the t, if the output depends on future, then we have to say that system as a non-causal. Okay, so see here, y of 1 equal to 3 into x square of 1 plus x of 1 minus 2 minus 1. Or you can take y of 3, whatever value may be, y of 3 equal to 3 into x square of 3 plus x of 3 minus 2, 1. 3 minus 2, 1. See, first 1. So this is 1. X square of 1 here only, plus x of minus 1. So this is the present value, minus 1 is the past value. So this is dependent on past value. Automatically we can say that this is dependent on present and past. We can say that as a causal. Next, y of 3, x square of 3, so present. X of 1, for 3, 1 is the past value. 1 is the past value. For 3 is present, then 1 is the past value. Okay, so we can say that the output depends on present, and this is the present one, and this is the past. Depends on present and past values for that one. So as the system equation output depends on the present and past inputs, we can say that is an causal system. So the system output only depends upon present and past inputs. Hence the system is a causal system. So this is regarding causal. If you want to say a system as a non-causal, the output depends on the future. So if there is x of t plus 2, then you get the future. So in this equation, if there is any term like x of t plus something, t plus something, then I can get the future values. So those type of system equations are called as non-causal system equations. Okay, now this is regarding which one? Causal system. Okay, and with respect to continuous time variable, if I want to explain this with respect to discrete time, what will I do? Just I will replace the small t with small n. So the equation, how can I give the example for a causal system of a discrete variable? I can write y of n equal to some 5 into x of n plus x of n minus 2. Y of n equal to 5 into x of n plus x of n minus 2. See here. So for n equal to 1, the first time instant, see, y of 1 equal to 5 into x of 1 plus x of 1 minus 2. 1 minus 2 is minus 1. 1 minus 2 is minus 1. See, at 1, okay, here in the output, 5 into x of 1, so the present input, x of minus 1, so with respect to 1, the minus 1 is a past. So here the output depends on present and past values. Hence I can say that system as a causal system. Clear? So this is the explanation regarding the causal system with respect to continuous time variable and discrete time variable. Now we'll move on to non-causal systems. See, now non-causal system, how can I explain that? Simple. If the system output depends on the future input, then I can say that system as a non-causal system. A system is said to be the non-causal if the output of the system depends on the future inputs along with present or past. It has to depend on future inputs. That is, in that equation, along with the present and past, if you have the value of future inputs, then I can say that system as a non-causal system. So there I had taken the example as y of t equal to 2 into x of t plus 3 into x of t minus 3 plus 6 into x of t plus 3. That is what I had taken. So for the present value of t equal to 1, you can take anything, t equal to 0, t equal to 1, t equal to 2, t equal to 3, whatever. So there they had taken t equal to 1. So it has to satisfy the condition for all values of t. If for one value of t, if I get the value of future input in the output, then I can say that is a non-causal system. So for t equal to 1, what is the system output? Y of 1 equal to 2 into x of 1 plus 3 into x of 1 minus 3. 1 minus 3 is minus 2. So 2 into x of t plus 3 into x of 1 minus 3, that is minus 2, x of minus 2 plus 6 into x of t plus 3. T plus 3 means 1 plus 3, that is 4. So the equation is y of 1 equal to 2 into x of 1 plus 3 into x of minus 2 plus 6 into x of 4. See, there with respect to 1, y of 1 equal to 2 into x of 1. 2 into x of 1 is 2 into x of 1 present. Next, plus 3 into x of minus 2. So minus 2 is there. With respect to 1, minus 2 is the past value. That is, it depends on present value and past value. Next, plus 6 into x of 4. 6 into x of 4. So 6 into x of 4. So here we have the 4. This is the value. Present 1, x of 1 and x of 4. That is a future. That means that equation output depends on present, past and future also. As the output is dependent on the future value, it is a non-causal system. And simply here the output is dependent on both past and future. So you can say that system is also a dynamic system, because if the output depends on past and future values, I can say that system as a dynamic system. So you can say this system is a non-causal system and dynamic system, but you can't say this system as a static, because static has to depend only on the present values, only on the present values. Now this system may be termed as non-causal system, the system may be termed as non-causal system and dynamic system also, and because it is depend on past and future values. If it is depend on past and future values, it is a dynamic. Here it is depend on future values. If it is depend on future values, it is non-causal. Okay, now see the equation what they had given. I'm writing here. They had given y of t equal to, they had given y of t equal to 2 into x of t plus 3 into x of t minus 3 plus 6 into x of t plus 3. Okay, this is what they had given. So for that I had taken the t equal to 1. Now if I want to explain the same thing with respect to discrete, how can I change? So same thing I have to explain the discrete. So I will replace t with n. So y of n. So I am explaining the non-causal with respect to discrete. Y of n equal to 2 into x of n. 2 into x of n plus 3 into x of n minus 3 plus 6 into x of n plus 3. Okay, this is the equation what that is given. Now see, for n equal to 0, so the output is y of 0 equal to y of 0. For t they had taken 1, for n I am taking 0. You can take anything. 0, 2 into x of 0 plus 3 into x of 0 minus 3, that is minus 3, plus 6 into x of 0 plus 3, that is plus 3. Okay, see there's the equation. Y of 0 equal to 2 into x of 0 plus 3 into x of minus 3 plus 6 into x of 3. Okay, now see, for this y of 0, so this is 0 point, equal to 2 into x of 0. X of 0 is that point, present input, plus 3 into x of minus 3. X of minus 3 is here. X of minus 3 is here. That means for 0, minus 3 is the past value. That is the output depends on past. Plus 6 into x of 3. For 0, plus 3 is the future value. That is the output depends on future also. That means the output depends on present, past and future also. Here the output depends on the future value. Hence we can say this system as a non-causal system. Are you clear? This is the non-causal system. This is the explanation for non-causal system. Okay. So in this way you can take a lot of examples. Let us take another example with respect to discrete. Say y of t equal to 2 into x square of t, 2 into x square of t plus 3 into x of t plus 1. So see, for this at t equal to 1, okay, so t equal to 1, how can you write? y of 1 equal to 2 into x square of 1 plus 3 into x of 1 plus 1, that is 2. 1 plus 1, 2. So at t equal to 1, the output of this one is y of 1 equal to 2 into x square of 1 plus 3 into x of 2. So see, this is the one point, first point. So at this point, what I need? X square of 1. So that is also at this point. That is here the output depends on present input. Next, x of 2. So with respect to 1, 2 is the future value. That means here the output depends on present and future. That is the future. The output depends on future value. Hence we can say this system as a non-causal system. So if you want to represent the same system with respect to discrete, how can I write? Y of n equal to 2 into x square of n plus 3 into x of n plus 1. So that system, the discrete system, is also an example for non-causal system. Okay, I hope you are clear with what is a causal and what is a non-causal system. And previously I explained what is static and dynamic. Now I hope you have a clear distinction between static and dynamic and causal and non-causal. So if I given an equation, so you can say whether it is a static or static system or dynamic system or causal system or non-causal, or it can be both. In some cases it is dynamic and causal. In some cases it is dynamic and non-causal. In some cases it is static and causal. Static and causal. So based on the given equations you can say. So you are clear with static and dynamic and causal and non-causal. For your better understanding, I will give some more problems for your work. Okay, students, for your better understanding, I had given 4 problems there for you to do at your home. So for your practice, do these 4 problems at your home. If you have any doubts, you can ask me. Okay, so these 4 problems are for your practice. So y of t equal to x of 2 minus t. 2 minus t plus x of t minus 4. Okay, first one. Next, y of t equal to x of t by 2. These 2 are with respect to continuous. And third one, y of n equal to y of n equal to sine of x of n. Sine of x of n. And last one, fourth one is y of n equal to x of 2n. So 2 with respect to continuous and 2 with respect to discrete. So this is for your work. So you have to verify whether the given signals are causal or non-causal. So you have to say the each and every one whether it is causal or non-causal. Causal or non-causal. So this is the examples that I had given to you to do at your home. Okay. Now I will go for the summary of today's class. Summary of the class. What I explained in this class. Okay. So I will go for the summary. Summary. So first, I started with the classification of systems. That here I explained the topic. First one, static and dynamic system. So in classification of systems, I already explained you 3 using the smart board. So in this glass board, the first topic is with respect to static and dynamic systems. So I started with static and dynamics. I explained you what is a static system, what is an dynamic system. Okay, so I had given you the general example, static person, dynamic person. So with the general example, I gone for the technical explanation of what is a static system and a dynamic system, and then I had taken some system equations for your better understanding. So with that system equations, so you are able to say whether that system equation is a static or a dynamic. So I had taken some examples. So I explained all this with respect to continuous time variable. So first I explained static and dynamic systems with respect to continuous time variable t. After that I explained the static and dynamic system with respect to discrete time variable, that is n. So I had taken examples with respect to continuous time and I had taken examples with respect to discrete time, and you are able to say the given system equation is a static equation or dynamic equation with respect to both continuous and discrete. So I explained all these 3 with examples. After that I explained you the topic. After that, what I explained? Next, after one, what I explained? Causal and non-causal. Causal and non-causal systems. Okay. So, what is a causal system? What is a non-causal system? And then I had given some examples. I had taken some system equations. So I solved those equations. Based on that solving, so we are able to say whether the system is a causal system or non-causal system. So first of all, here also I had explained with respect to continuous time variable, small t, and then I gone for the discrete time variable small n. That is, I explained causal and non-causal systems with respect to continuous time variable t and discrete time variable n. So I had taken the system equations with both continuous and discrete, and I explained you how to verify whether the given system equation is a causal system or non-causal system, and then how to distinguish this static dynamic with respect to causal and non-causal. So when a system is given, so whether the system is static or dynamic or causal or non-causal. So I had explained you. So don't go confused with these two. So because they are almost interlinked. Okay. So the concept is same like both. Okay. So for this reason, some system equations may be causal and dynamic. Some equations may be causal and static. Some equations may be non-causal and dynamic. So I also explained which one is causal and dynamic, which one is non-causal and dynamic, which one is causal and static. I explained everything. So now I hope you are all able to distinguish this is a static and this is a dynamic and this is causal and this is non-causal and which one is causal and dynamic. So you are all have a perfect idea about all these 4 types of systems. So you can able to distinguish. And finally, I had given you 4 problems or 4 examples for your practice regarding causal and non-causal. With respect to causal and non-causal, I had given you 4 problems, 4 examples. So those 4 examples you have to do at your home for practice. So this is today's class problems. Thank you.